Today we're going to solve lesson 11, the first homework that we have for this second semester. Remember, I'm going to put the solutions so you can compare and have all your points in this second semester. So we're going to start with lesson 11. Remember that I assigned pages 133, 34, 35, and 36. So I'm going to do 133 and 34 so you can start working on your assignment. So we're going to start, remember, always with a review of our assignment. So for example, we're going to identify proportional relationships. That's the lesson 11. Represent proportional relationships. Where we're going to start with the vocabulary. We're going to have proportional relationship, a numerical relationship that can be represented by equivalent ratios. And we're going to explain that one in a minute. So for example, suppose that you are buying grapes at a farmer's market. The cost of the grapes you buy depends on how many pounds you get. Two different stalls sells grapes at the market. Find the ratio of the cost to weight for each pair of values in both tables. Remember, what we usually do is we count. For example, in stall A, we have the weight in pounds. So it goes 2, 4, 6, and 8. So it goes by 2. So the total cost goes 4, 8, 12, and 16. It goes by 4. So this one goes by 2, and this one goes by 4. So now what we are going to do? Well, let's do a stall B. So I have 2, 4, 6, 8 goes by 2. Then I have 8, 10, 12, 14 goes by 2. So let's see. So in this case, we're going to do the relationship. We're going to make the division as we saw in class. So we have 4 divided by 2 is 2, 8 divided by 4 is 2, 12 divided by 6 is 2, 16 divided by 8 is 4. That's the proportional relationship. Now here in this case, we go 8 divided by 2 is 4, 10 divided by 4 is 2.5, 6 divided by 12 is 2, and so on. So the changes are different. So if a group of ratios are equivalent, they are part of a proportional relationship. Stall A, they are the same, so it's a proportional relationship. The relationship of total cost of weight in stall A is proportional. In stall B, as you can see, you have 4, 2.5, 2, and 1.75. It's not the same, so it's not proportional. So I'm going to mark like X. Problem 1, and these are basic problems, all these ones. These are basic problems. It says plot a point for each of the first 3 ordered pairs in each table. Connect the points for each relationship by drawing the line through the points to the y-axis. So we're going to start, for example, with the point 2 and 4. Remember that this is the weight in pounds. This is the weight. And then we have the cost. And X. So what we're going to do, I have the weight in pounds is 2, so I have 2, and then the total cost is 2, so it's this point here. Okay, 2 and, well, in this case it's 2 and 4. 2 and 4 is this point here. Then we go to 4 and 8. Here is 4 and 8, so I go 4 and go to 8. Then I go 6 to 12. Here is 6 to 12. So I have 6 and goes all the way to 12 here. 12. So those are the 3 points. What I'm going to do is put those points together and I'm going to form a line. So remember, goes all the way to the y-axis. I'm going to do it this way. Here and draw the line. Okay, this one is stall A. Now let's do B. To do a stall B, I'm going to use a different color. For example, I'm going to use blue, and remember we go to 2 to 8, so I have 2 and 8. Okay, that's the first one. And then I'm going to have 4 and 10, 4 and 10 here. And then I'm going to have 8 and 14, 8 and 14 here. So we put those ones together. and this is a stall B. Okay, here we go. That's problem A. So that's easy as plugging in those points and make a line. So problem B or 2, look at your graph in problem 1. Does the line for either of the proportional relationship or the relationship that is not proportional go through the origin? If so, which relationship? As you can see, 0 is the origin. This is origin. And it's only 1. That's still A. So in this case, you can say the graph of the proportional relationship connects to the origin. Okay, this is the proportional relationship. Remember that A was the proportional relationship. That one is the only one connecting to the origin or 0. And then problem number 3, suppose the cost of 10 pounds of grapes in stall A is $15. Will the relationship still be proportional? Explain. Remember that to find the proportional relationship is a division. So in this case, for example, I'm going to do $15 to 10 pounds equals to 1.5. And remember, what was the proportional relationship? 2. So in this case, my answer is no. The ratio 15 over 10 equals 1.5, not 2. So the ratios will not be equivalent. Okay, that's the solution. So they are not equivalent because the division, 15 over 10, does not give you equals to 2. Now let's move to page 134. So we're getting there. So we have another 2 tables. Okay, this is a medium problem now. And 5 is going to be a basic, 6 is going to be another medium problem, 7 is going to be more complex analysis. So you have the number of cups of water used in the 2 different soups recipe depends on the number of batches of the recipe you make. The table shows the number of cups of water used in the 2 soup recipe. So you have recipe A, you have the batches 2, 4, 6, 8. Remember, every time we're going to 2, 4, 6, 8. So it goes by 2. Then you have 6, 12, 18, 24. So it goes by 6. Then recipe B, you have 1, 3, 5, and 7. Goes by 2. 1 plus 2, 3, 3 plus 2, 5, 5 plus 2, 7. Then I have 4, 12, 20, and 28. Goes by 8. Okay? 4 plus 8 is equals to 12 plus 8, 20 plus 8, 28. Okay? So do the ratios of the cup of water to batches to soup in each table represent a proportional relationship. Explain. Okay? Explain. In this case, yes. I'm going to say yes. Let's divide. 6 divided by 2, 3. 12 divided by 4, 3. 18 divided by 6, 3. So it's 3. And here, 4 divided by 1, 4. 12 divided by 3, 4. 20 divided by 5, 4. So it's a proportional relationship, both. So in this case, yes, the ratios of water to batches in recipe A are all equivalent to 3. And the ratios of water to batches in recipe B are equivalent to 4. Remember what we do is, I'm going to do it here. In recipe A is 6 divided by 2 is equals to 3. 12 divided by 4 is equals to 3. 18 divided by 6 is equals to 3. And then we go to the second table, 4 divided by 1, 12 divided by 3, 20 divided by 5, 28 divided by 7, all are equals to, in this case, 4. And look at this one, constant rate of change, 8 and 2. 8 divided by 2, 4. So it's a proportional relationship. Let's go to problem 5. So in this case says, the graph shows the data from the tables in problem 4. These tables here. Which line represents recipe B? Explain how you know. Remember, we were just graphing this one. So these are batches and these are the water. So I'm just going to have, for example, 1 and 4. Where is the 1 and 4? So which recipe? B. So in this case is this line, the black one. So how do we answer? Graph shows the data. So in this case, the black line represents recipe B. It goes through the points 1, 4, and 3, 12, and so on. The points that we have here, okay? 1, 4, 3, 12, 5, 27, 28. Okay, number 6. Use the graph that you identified in problem number 5, okay, for recipe B to find how much water is needed for 4 batches of soup. Look at this one, 4 batches of soup, and we go, how many cups of water? 16. That's the way I'm using the graph, okay? 4 batches of soup if the ratio to batches equivalent to the ratios to found in the recipe B in problem 4. So we're going all the way here. Remember that this problem is 4. So we go 4 and 16. Okay, so the answer, because we're using the graph, is kind of a medium problem. So in this case, 16 cups of water. Remember that we found it just going batches, 16 cups of water. And in this case is yes. The ratio, 16 over 4 is equivalent to 4. Okay, it's equivalent to 4. That's what we were looking for. Now we're going to the last problem. It says, Tomas collects sport cards. The number of baseball cards he buys each week is proportional to the number of football cards he buys. A. Fill in the missing number in the table. B. Suppose Tomas buys a total of 30 baseballs and football cards in week 5. How many of each will he have to buy to keep the same proportional relationship? So in this case, we go 9 to 15, okay? Then we go to 12. This is going to be 12, and this is going to be 6. How do I figure out? It's going, in this case, 6, 12, 9, 15. And then the number of football cards, I have 6. Then I have 8. And then I'm going to say this is going to be 10. And then this is going to be 4. Okay. So suppose Tomas buys 30 baseball cards and football cards in week 5. So we have a week 5 here. Okay. So what we are going to get. So in this Tomas, Tomas without H is Tomas will have to buy 18 baseball cards and 12 football cards. So that's the first 2 pages, okay, of the homework. So in this case, if you have any questions, you can email me. Remember, don't get behind with your assignments. And later we'll put the second part of this assignment.